Hi everyone and welcome back to Mossy Maths GCSE. Today we're going to be going through a lesson for the higher tier which looks at recurring decimals. Now recurring decimals are kind of an extension to fractions, decimals and percentages as a topic, and we're going to go through the key points and 3 example questions. And for this we're probably looking at 3 or potentially even 4 marks. And they're not particularly challenging questions once you get to grips with how we approach them. Now, the key points here are using dot notation. Now, we say a recurring decimal is where we have a value where it continues on and on to infinity. For example, if we write something as 0.57 recurring, now the dot above the 7 shows that the 7 is the recurring value. This is what we say is 0.5777777 and on and on and on to infinity. So the 7s will continue forever. The 5, there's only 1 because it doesn't have the dot above it. 0.2 recurring 7 recurring, like this, with the dot above the 2 and the 7, is written as 0.2727272727 and on again to infinity. So the 2 and the 7 recur forever in that pattern, in that order. Now if you see something like this, 0.586 with the dot above the 5 and the 6, now because the dot is above the first and the last value, this means that the 8 is recurring as well. We just don't need to write the dot above the 8. It's a pointless exercise because that means this must recur also. So if you see any value, it could be an unlimited number of values, it could be 0.8672 or whatever it is. If the dot is above the first value after the decimal point, and the last value, that means all the values in between will recur. So this would be 0.586, 586, 586 and so on. For example, if you want to try this one at home just to see if you've understood that, write 0.828282 and so on in dot notation. Just pause the video and have a go. Okay guys, hopefully you've had a go at that question. So the way we write this in dot notation is similar to this one. It will be 0.82 with a dot above both of them, okay? So that is how we write this in dot notation. Now, we're going to go through some examples, and we've got 3 here to go through. Now, the amount of times I've written examples, we could probably write that in dot notation. We have to convert 0.1, where the 1 is the recurring value, to a fraction in its simplest form. Now the way we do this is we write this, first of all, in decimal notation. So we say x is equal to this, which is 0.111111, and so on and so on. Now, if we're trying to convert this into a fraction, of course it's not easy to see how we do that. So what we have to do is we have to try and eliminate this recurring value. And the way we do that is by multiplying by a factor of 10. Now if we have 1 value recurring, we multiply by 10. If we have 2 recurring values, we multiply by 100. If we have 3, we multiply by 1,000, and so on and so on. Now here we only have 1 recurring value, which is 1. So we multiply by 10. So we can say that 10x, if 1x is 0.11111, then 10x is 1.11111, and it will still recur. However, hopefully you can see now what we have. Because if we subtract x from 10x, we're going to get rid of this recurring value. Because the 1's go on forever, and here we have 0.11111, if we subtract x from 10x, we're actually going to get a fraction. Because 1.111 and so on, subtract 0.11111, is going to give us just 1. They're going to cancel. This, after the decimal point, will disappear. So we're just going to end up with 1. But of course we subtracted here x from 10x, this from this. So we need to subtract this as well. This is equal to 1 out of 10x minus 1x, which is 9x. But we don't need to write the x, we've just made that up. So this is just 1 divided by 9 as a fraction. So hopefully you can see what we've done there. We've taken x to be the value in its form that is not using dot notation, so we've transform this from dot notation to a value we've called x, we've multiplied both sides by 10. Now the left hand side will be the denominator of the fraction, the right hand side is the numerator. So by subtracting x from 10x, we've got rid of the recurring decimal and we've been left with just a value of 1 on the numerator, and then we've subtracted the x from the 10x to give us the 9 on denominator. So just to show you how that works with this one, show that 0.1 recurring 8 recurring is equal to 2 divided by 11. So again, we turn this into a value first of all. Well, here we've got 2 recurring values, so what we're going to get is having to multiply by 100 to get 100x, to get rid of this recurring decimal. So x we call this, which is 0.181818 and so on. Now we know, because we've got 2 recurring values, that if we multiply by 10, we're not going to be able to subtract x from 10x, because that's still going to give us a recurring value after the decimal point. We're going to have to multiply by 100, but I'll show you why it doesn't work. So if we multiply by 10, we're going to get 1.818181, and clearly this subtracted from this isn't going to get rid of that after the decimal point. However, if we multiply this by 100, then we get 18.181818 and so on. Now, if we subtract x from 100x, this 18 after the decimal point will cancel and we'll be left with just 18.018. So on the top, we're going to get 18.18 and so on, subtract 0.18 and so on, which is going to give us 18. And on the denominator, we're going to get 100 minus 1. 1x subtracted from 100x, which is 99. So as a fraction, we're going to get 18 divided by 99. Again, we can simplify this down. We could first of all divide by 3, which is going to give us 6 on the top. And on the bottom, we're going to be left with 33. And again, dividing that by 3, that gives us 2 divided by 11, which is what we're asked to find. So that works. Now for this one, if you'd like to try that at home, just give it a go, and then I'll go through the solution with you afterwards. Okay guys, hopefully you've given this one a go at home. So x is equal to 0.28888 and so on. We've got one recurring value, so let's multiply by 10. Okay? So, with that, we're not really going to get anywhere, because we have the 8 that is recurring afterwards. So what we need to do is to eliminate this whole thing. Now if we multiply by 100, we're going to get 28.8888 and so on. Now hopefully you can see that even though one value is recurring, it's a second value, so that makes it more challenging here. But we can actually use these two, because we've got 0.88 and so on here, and we've got 0.888 and so on here. So instead of subtracting 1x from 100x, we're actually going to have to subtract 10x from 100x to get rid of the values after the decimal point. So on the numerator we get 28.88 and so on, subtract 2.888 and so on. Now that's just effectively 28 minus 2, because the 0.88 will cancel after the decimal point, which equals 26 on the numerator of the fraction. On the denominator, we're going to get 100x minus 10x, which is 100 minus 10. Again, we don't need to consider the x, that's just a value we've made up. So on the numerator we have 26, and on the denominator we have 90. Now what can we do with this? Well, we can divide by 2 to simplify it, because both have factors of 2, and we get 13 divided by 45, which is the simplest form of this recurring decimal. So thanks a lot for watching the video. If you do have any questions, leave them in the comments section. If you found the video helpful, please do leave a like, and if you haven't already, please do subscribe to my channel. That was a lesson on higher tier recurring decimals, and I'll see you in the next lesson.